What is the oxidizing agent in the following? So we're going to pick up where we left off. Now, we're going to remember that the oxidizing agent is what is going to be reduced. So on the left, it's going to be a higher oxidation number, and then on the right, it will be a lesser number for the oxidation state, because it itself is going to be reduced while it oxidizes the other one. So what we're going to have to do is find the oxidation states of each element or atom in the compounds. So let's start off with an easy one. We have bromine right here, and it's a negative and it's a gas. So this is just equal to its ion here, so it's just -1. Now let's go back over here. So let's look at bromine in the compound of bromine here. So if we have bromine and then we have oxygen, and we has to equal this -1 charge as a compound. So we have 1x, we don't know what bromine is yet. We have 3 oxygens that are -2, and this must equal the oxidation state of -1 of the compound. So when we solve for this, we're going to get x is equal to 5, because we add the 6 on the left and to the right-hand side, and then we get -1 plus 6, so that's 5. So we have bromine here is 5, and then it becomes -1, and oxygen is -2 for each one. Now, we could stop here because we notice that 5 going down to -1 means that it is itself being reduced. So our oxidizing agent would be considered bromine trioxide. So we have, this is our oxidizing agent because it itself is being reduced, specifically the bromine. So then we would say our reducing agent would be the other compound. So we don't even have to go on any further. So now let's look at another example. Now we're going to identify the oxidizing agent and the reducing agent for the following. So we have this reaction, and so what we're going to have to do is find the oxidation state for each one. So this one's easy, as it's just equal to its charge of +2. Now let's do our other product. So we have a -2, so it must equal -2. So we have 1 sulfur. So we're going to look for sulfur. We have 4 oxygens, which is -2. And this will be equals to all -2. So we have 1x plus -8 equals -2. So 1x is equal to 6. So sulfur is equal to +6. Oxygen is -2. Now let's look over here. Let's label this so we know where it's occurring. If we have Mn04 negative, this means we have 1x. We need to solve for the oxidation state for here. Plus we have 4 oxygens, which is -2, which is equal to -1. So we have 1x minus 8 equals -1. So x is equal to then 7. So the oxidation state is +7. And then we have -2 for oxygen. Now let's look at SO3 to negative. So we have 1x for the sulfur. So we're trying to find the oxidation state for sulfur because this is going to equal -2. And based upon the chart, we're looking at oxygen being -2. So we have 3 oxygens. So 1x is equal to plus -6, and we have equals -2. We add 6 to both sides, and we get x is equal to 4. So sulfur is going to be +4 and oxygen's -2. So now that we kind of have this all in its oxidation states for each atom or element inside every compound, now we can look to see what is being oxidized and what is being reduced. So we notice that oxygen is just staying the same. So oxygen's not a player in this, in the sense of what's being reduced and what's being oxidized. So we're looking at Mn and S. So we notice that Mn went from +7 to +2. So if it's going from +7 to +2, that means it's being reduced. Then let's look back at the other one. So we're looking at sulfur. Sulfur is +4, and then it becomes +6. So sulfur is going from +4 to +6. So it is being oxidized. Now that we know what's being reduced and oxidized, now we can look for what's our oxidizing agent and what's our reducing agent. So it can only be a reactant. Nothing can ever be a product for oxidizing agent or reducing agent. And we notice that if something is being reduced, then we would say the oxidizing agent is equal to MnO4 negative, because it itself is being reduced and it is therefore oxidizing the sulfur. So our reducing agent then is SO3 2 negative. So we would include the whole compound as the reducing agent or the oxidizing agent. Now let's do another example. Identify the oxidizing agent and the reducing agent for the following. So here we are back at our glucose, and we have carbon dioxide and water to make oxygen and glucose. So let's find the oxidation for each one. So if we start with carbon dioxide, we know this is going to be -2. And then there's 2 of them. So carbon has to equal an overall charge of 0. So we have 1 carbon. We'll do that. Plus 2 -2s equals 0. So carbon then must equal 4. It has to equal +4 in order to keep the oxidation state of 0, because this compound is neutral. There's no charge, so it has to equal 0. Now, if we look at water, so we have oxygen, which is going to be -2, and we only have 1. And we have 2 hydrogens, so it's going to just be 2 + 1. And when those are added together, we get 0. So we know that hydrogens +1, oxygen's -2. Then we remember our rules. If we look back at rules 1, anything by itself, a diatomic or monatomic, with no charge is equal to just 0. So oxygen is now 0 here. Now let's look at glucose. So we have C6H12O6. So we have 6 carbons. We have 12 hydrogens, which is going to be +1 for each hydrogen. And then we have 6 oxygens, which is -2. And this must all equal 0 because there's no charge on the glucose. So 6 carbons plus 12 minus 12 is equal to 0. So 12 minus 12 is going to be 0. So we have 6 carbon is equal to 0. So therefore, carbon must equal 0. So carbon here is 0, hydrogen's just the positive 1, and oxygen's negative 2. So now we've dealt with the oxidation states for each atoms in the compound. So now we can looking over what's being reduced and what's being oxidized. So we can see that carbon right here is positive 4, and then carbon here is 0. So our carbon is going from positive 4 to 0 in oxidation state in this reaction. So if it's becoming less, we're saying it's being reduced. And anything that's being reduced then, we can look at that compound as being our oxidizing agent. So our oxidizing agent is carbon dioxide. Now let's look for the other one that we need to see. So we see oxygen here's from 0. And then we have on the left-hand side, it's equal to negative 2. So this is becoming, and we're just going to deal with one of these. So one of these oxygens, like these two oxygens, are then therefore becoming reduced. Now the other one will stay the same. See, it's negative 2 and negative 2. So we're just going to deal with this one. So oxygen is going from, on the left-hand side, it's negative 2, and it becomes 0. So this means it's becoming oxidized because it's increasing in number. So therefore, our reducing agent, as it has to be on the reactant side, is going to be our water. Now let's do one final example. So we're going to identify the following oxidizing agent and the reducing agent for the following. So we have 2 Mg plus O2, which is equal to 2 MgO, or magnesium oxide. So let's find the oxidation states for each one. Now we remember rule 1. This is a solid because there's no charge on it, so we know it's magnesium solid or magnesium metal. So if we have magnesium metal, this is therefore the oxidation state of 0. Anything that's a diatomic is also 0, so that's 0. Then we look at magnesium oxide. So magnesium oxide is neutral, so therefore we know it must equal 0. Oxygen's usually negative 2 based upon the chart, because we don't know what magnesium is, so we're going to have to find it. So what's magnesium? Well, in order for this to equal 0, magnesium must be positive 2. So magnesium's positive 2, oxygen's negative 2. So we can see that magnesium is going from 0 to negative 2. So we would say it's being reduced. And then we would say oxygen is going from 0 to positive 2. So we would say this is being oxidized. So when we look for the oxidizing agent and reducing agent, if magnesium is being reduced, then therefore it's the oxidizing agent of magnesium solid. So this is our oxidizing agent. Now, the oxygen is being oxidized, so therefore our reducing agent must be O2. Now, we also know that it's the only other reactant in this, and you have to have either an oxidizing agent and a reducing agent in order for to have a redox reaction. So we have solved for this one. And now let's do some half reactions for the following. But let's take a little break.